Okay, good day viewers. Thanks for joining me for today's video. Today's video will be step 2 from my last video that I posted. So in the last video, I talked about this particular project. This is the architectural layout and an existing document for the structural drawing, which I said it has been signed and sealed, and I showed the discrepancies from comparing the architectural layout and the structural layout. So moving on, I have made preliminary design options for this particular architectural design project. It's a real life project, so already documents are in place for the construction, and it's been reviewed just like I mentioned in my previous video for the architectural drawing based on the discrepancies that I noticed. So with that, I have made a general arrangement for my ground floor, first floor, second floor, third floor, and then the roof plan for the roof general arrangement as well. So I have option 1, option 2, and option 3. Now, if it were to be in other climb where construction is standardized and equipments are readily available, then option 2 might be something that will be very viable. So option 2, I made a recommendation for flat slab construction for the floors, but in option 1 I made recommendation for beam and slab arrangement for the construction. Then option 3 is also beam and slab arrangement, but in this case I will have a case whereby the columns, okay, from here some of the beams will have to be cantilevered out so that it can support the beams at the edge. These beams at the edge, which will cover this area of the design. So, but generally I didn't go further with option 3 because the thing is that the design is for an event hall, so there won't be issue if these beams are visible, after construction. So with that in mind, I felt like there's no need for us to go ahead with this option 3 where the beams cantilevered out, and these cantilevered beams will now support this beam that will be on the edge, that will be sitting directly on the walls on this side, so that if it were to be for other use, probably if it were to be residential, then we might need to hide some of these beams so that it won't be visible in the rooms. But this case being an event hall, so I felt that does not really matter in this case. So we will only talk about option 1 and option 2. So I took time to make the general arrangement for each floors, both in option 1 and option 2. Now in option 1, which is beam and slab arrangement, so I have made this arrangement. Now, as much as we will be talking on a few things, probably the viewers of this video, for you to actually grab some of these things, you might have to pause this video at some point and look at the general arrangement in relation to the architectural layout. So you might need to pause the video and have a better view. So this is the end part on the ground floor. So mind you, on the ground floor, okay, then let's talk. The The recommendation of the soil investigation. Let's start from there. The recommendation of the soil investigation is that the structure will have to be founded on pile caps and pile. So, which is pile foundation. That's the type of foundation recommended for this structure. The soil investigation engineer recommended pile foundation. There's no room for any shallow foundation. So the recommendation is that pile and pile cap foundation. So with that in mind, this is the arrangement of my tie beam that will eventually support my ground floor slab. So this is the arrangement. This is the general arrangement. Now, one thing I want to correct, because I noticed that most times, even in construction out there, we have some construction arrangement that when your foundation is on a pile and a pile cap, I still have some engineer in practice that the ground floor, they will still design these ground floor beams as raft and slab beams. So by so doing, you are increasing the cost of construction. So there's no need for that if you have determined the finished compound level and the finished ground floor level on your side. Then the next thing for you to do is to suspend the ground floor. So that means you have to design the ground floor just like you are designing your suspended floor. So you have the beams and you have the slab, which will now have bottom reinforcement at the spans, then top reinforcement at the support. While the other way around, if it were to be raft, then you have the span reinforcement at the top, then you have the support reinforcement at the bottom. So most times, if you are designing a pile and a pile and a pile cap kind of foundation, the next thing for you to do is to provide tie beam, then provide your ground floor. That means you have to suspend your ground floor. So what it means is that your tie beam will be spanning depending on how you have determined your finished ground level and then finish compound level. Then you know how to place these beams at whatever level. So beams of 600 will be fine. Even 450 will still do the job at the ground floor level. So these are my tie beam and these are my ground floor slab, and this is the arrangement. So on this floor now, you will have slab on all these places because it's your ground floor. So there's no need for you to have opening at this level. Now this is the column that was missing in the previous structural arrangement which I pointed to. So this is the whole arrangement. Like I said, you might have to pause this video to actually view this thing. So during your construction, you will have starter bars for your staircase. By the time you are doing the concreting for the ground floor slab, you also have starter bars for your staircase here. Then you have your starter bars for your lift shafts that will be coming from the foundation. So this is the general arrangement for the ground floor. Now, similarly, in the option 2, which is the flat slab, we also have the same kind of arrangement. There won't be any difference. The difference will only start from the first floor, which will now be the flat slab kind of arrangement. So coming again to the first floor now. Now the first floor, just like we have it here, there's a void here and there will be a staircase which will also be kind of an opening. So that is what we have here, and you can see the beams arrangement, and this is the void. So there's a beam that will extend up to this point. So by the time we are doing the arrangement of reinforcement, we will know how to arrange reinforcement around this particular area where we have opening, because we have to provide reinforcement for some additional reinforcement at the corners from this point to this point. So when we get to that point, we'll solve it. Then Again, we'll look at the cantilever that was missing. Now, in the previous drawing, the structural engineer's cantilever only extend up to this point. But just like I showed you in the elevation that the cantilever extend beyond this point. So the cantilever is up to this point. So I have made that correction in this arrangement as well. So and that's how you have that cantilever on this side, on this side, and on this side, and on this side. So everything is recorded and taken care of. Like I said, if this is not done properly, then definitely some loads will be missing, which will not be considered during the analysis and design stage, and that can be a source of problem later on. So everything has been taken care of here. So we have staircase here, which it will be a void during our design and analysis. Then so the staircase will be designed separately. So then we have slabs in all this area. So then this there's also staircase here, and there's a lift shaft here, which is on our architectural layout. So everything is carefully spelled out, everything is carefully laid out, and everything is carefully considered in the general arrangement for our structural design and analysis. So void, everything taken care of. So on this floor, there are walls sitting on the edge of this cantilever at this point and this point, and it goes like that. So that has to be considered when you are analyzing your structure, when they are designing. So you have to make sure that you make provision for the load of that wall, because the wall extend up to the third level. This is the wall I'm talking about, this wall. So the wall is slant, so that means at this point the cantilever projection is quite different from the one on the first floor. So that has also been considered. So moving on to the second floor. Now this is where there's a void, and there's a staircase that only stops at the first floor, so it does not go up to the second floor. So this is the second floor general arrangement as well, which is this. So you can see that the staircase from that floor does not extend up to this floor, so the staircase is not considered. So everything is slabbed. So and same thing, there's a staircase here, same for the cantilever. Now on this point, now in this floor, now what I want you to note carefully is that you can see that this lines is showing on the second floor, but coming to this this elevation, you can see that cantilever does not actually project out from that floor. Rather, we have some aesthetic features that it will house, maybe flower pots or AC outdoor unit. So all this is on another level in the structure. So if you don't look at this carefully and correlate the architectural layout with the elevations, you might think that, okay, all this cantilever, that was why I purposely left the cantilever, at this stage, so that we'll look at it together and we'll know that, okay, so from this point, this architect is rather showing that this slab is seeing it, he's seeing, if you are looking at the layout of the second floor, you are probably seeing this one on the first floor. So distinctions have to be made, because you can actually go ahead and model everything and thinking that the slab still extend up to this point on the second floor, but looking at the elevation, the slab does not extend. So that means we don't have this slab up to this point in this arrangement for the second floor. So the slab will have as cantilever will only extend up to this point. So there's no need for the slab. So it will just be like this. That was why I made the special, I color code some of these things So the slab will only extend to cover up to this area. So that was why I left it, so that we can look at it together while I'm making the video, so that so the slab does not actually extend up to this point. This is where it extends up to on second floor. So which means that slab is only the slab that will support this wall area on this way. So the slab does not extend up to this point, which is the cantilever as shown here. So it only extends up to the end of this wall. So again, it goes that even the architect that is making design drawings and dishing it out, so like this, I understand that he's supposed to make it with probably a dash line, or if that is not done, then he will make annotation that okay, this place is below. Like I said, he did a good job at but then we still notice some of it now. As in this case now, there's a terrace here, and he indicated a terrace below. So which is actually, this is the roof level, but this terrace, because when you are looking at the roof, this is a plan, you will see this terrace as well. So he indicated terrace below. So, and let me show you the 3D. Like I've said, I've modeled it before, so you can see that the terrace is here. And what I'm making reference to is that you can see that the cantilever extend up to this point on this floor, but it does not extend up to that point on this floor. It will only go to the third floor where we have the cantilever, and it is not the same length with the one on this floor, because this wall that I modeled here is actually a slant wall extending from here up to this point. So that was why I left that, so that we can make that distinction together. So on this floor we'll have something like this. So this is not, the slab does not extend up to this point in this case. So this is where it extends up to. Let me quickly join this. So I hope you understand. Then let's trim this up. So that is where the slab actually extend up to on that particular floor. So then every other thing, so the same thing that happens here will happen here, will happen here, will happen here, for the sake of time. So I hope it is clear. Then we have the slab arrangement as before, and like I said, this portion only stops at first floor. It does not extend up to the second floor. So that's why we have all the slabs here, then the lift shaft and the staircase. Then going to the third floor. Now the third floor, just like I've pointed out, the projection of the cantilever is actually lesser compared to the one on the first floor to accommodate this slantness. So that has also been considered, and everything is well laid out here, corrected. So everything is there on this floor, which is the slab, the beams, then the cantilever. Then we now move to the roof arrangement. So with the roof, we have short cantilever slab, inside, because the roof is actually recessed from the final elevation, where we have all this aesthetic wall on the roof level. These are the wall. So the roof is actually be within inside, so it won't be visible after construction. So then we now have a cantilever away from the wall, and we have slabs at the lift shaft and staircase area, where you have the water tank that will be placed there. Then we have one aesthetic slab that is up at this level, extend up to this level. So, and that is what we have here. This is the slab This terrace is actually on this floor, so you are not going to see it in the general arrangement for the roof. So, and these are the slabs that I just model here. Then the roof will be sitting. Probably there will be a dwarf wall kind of here, or a small beam that the roof will now be sitting on. So, and that is what we have here. So you can see the 3D here. You can see that this is the slab because it's actually slide projected, from the final level on this roof level. So how I got this projection, it was from the 3D design that the architect made. So that was how I was able to get the distinction. But if you are looking at the plan, you are not going. It didn't specify the level on this place. So probably if you are looking at it as a plan, you would think they are on the same level. They are not. I actually got that level from the 3D. Then from the elevation, you can see that this slab projects slightly above the final wall or dwarf wall height of that structure. So that was how. Then the opening this area, I have to now shift the column. So in the end, I will have a column that will be sitting on the beams. So going to the option two, which is a flat slab kind of construction, because like I said, if it were to be in other climb where construction is standardized and equipment are readily available, then this option would have been, another viable option. So, but in this option, by the time you get to the roof level, you will have some challenges whereby you might have to now introduce beam at this place, or probably you introduce a drop kind of beam that will extend like this up to this point. Then you have the same, it will not be a kind of dropping because of that roof level arrangement where this slab is being placed. But because now these columns have to be shifted from here up to this point, so by that it will be sitting on a beam. So same thing, this column is now shifted up to this point because of that. So same thing with this column shifted onto now be. So you would notice that better from the 3D. You can see shifted and is now sitting on a beam. So same thing, but in this case, I just have a dwarf column that was placed because there will be roof slab here. So I just placed that on this column on this level. So I just left this as it is from this 3D. So that is that. So like I said, going by this, you might need to now have additional beam, to support the columns that will be shifted to accommodate the final slab on that roof level. So then again, one thing I want to point out is that during analysis, when we get to that point, I will show that there's what they call axial shortening. I will show you the documents that the designers of software, which is Prota structure we are talking about, the designers of software published, because there's an interaction between the lift shaft wall and the adjoining beams. So sometimes it might require you to place column at the edges of this, or you might actually leave the wall to be joined with the beams. So design consideration wise, design wise, analysis wise, there's a document to that effect that shows you that tells you what to do based on whatever model you have modeled. When we get there, we'll cross that bridge. So this is the flat slab kind of arrangement, so probably similar to the beam and slab arrangement. The only difference is that you don't have beams, you only have flat slab and column. So during analysis, you might have columns that will need drop panel, or you might have a combination of column and drop beam, this kind of beam arrangement. So aesthetically, this will be very sweet you know, given that it's an open space and you will not have drop beams, visible for the users of the building. So that is the sweetness of this flat slab. Then construction will be quicker and faster considering the beam and slab kind of arrangement. Aside the fact that you will have some challenges when you get to the roof level if you want to make this kind of arrangement where you have all this slab and so then above all we now have to put in the Nigerian factor. That is for the Nigerian audience, Nigerian viewers. The Nigerian factor comes into play, and the Nigerian factors are numerous. We don't have standardized material. We have, not like we don't have, but they are not well standardized. So we have issues in that regard. Then you also have to consider the clients. What is the capacity of your client? That is another thing you have to consider, and also who are going to execute the project. So you as a designer, all these things have to play very important role in your choice of structural option for your project. So because if you do not consider all these things, somebody else is going to except in a case that you are the prime consultant. So that means you take the design, you take the execution, you are bringing in your expertise, you are bringing in your workers, and you monitor everything from start to finish. If that is not the case, which is rarely not the case, then you have to consider that it's somebody else that will construct it. So these factors will go a long way to help you make a choice of the type of construction you want to adopt for the project. So it is very, very important from the strength of the material you are using, your reinforcement, your concrete. If it is a private person, you need to consider the finance of that person. The person might not be able to afford an higher grade of concrete, so you also have to put that in mind. Same thing for the cost of reinforcement. If you are buying higher grade of reinforcement, quality reinforcement, the price is higher compared to if you are buying local. So all these things you have to put into consideration. Now you have to also have in mind that the local material is not well standardized. So that also have to come to play when it comes to your choice of strength of the material you want to use. So these things come into it. Then another thing I want to cite is that when it comes to foundation generally, there's a there's this practice that if you have wall and your foundation for your wall, there's supposed to be foundation for your block wall. But what I notice most times in practice is that even this is being done by professional. For your wall, they will say it is blinding. No, there's nothing like blinding your wall. Yeah, if you follow construction technique, have blinding, have foundation, and the recommended thickness of foundation for your wall is 225 minimum. So we have in practice, we have people constructing 75 mm. They will now say it's blinding for the foundation wall, and they start placing. So and after some time you start seeing cracks in the wall. So this also comes to your foundation wall needs a foundation, and the minimum recommended is 225. But it's sad that even professionals, engineers who are schooled and well, goes and practice otherwise. I say it's just a wall. So this thing have effect on your structure. Now, given our terrain in this country, yes, we have places like Ikorodu, Songo, that their soil is very strong. So maybe if you have 150, 100, you can still be fine. But anything below that, 75, 50. I've seen 50. By the time I went to one side and one guy was telling me, I know one senior engineer registered. He used to do 50, 75 mm. But I said, so these artisans, some of the things they practice, they even learn it from professionals as well. So let's try as much as possible to follow standard and do that. Yes, you might be considering cost and all, but you figure out that most of these things have even been costed with the BOQ, but yet when it comes to execution, you want to cut back on the spending, which is not right. So whether you like don't, even if you are doing 150, like I said, if it is a place like Ikorodu, Songo, places with very good and very strong, Abuja, very strong, laterite, then 100, 150, you can still get away. But below that, whatever it is, however strong your soil is, it is still subject to movement in a way, because whether you like it or not, there's seasonal change. So there will be time where water will be part of your structure, and there will be time where water will dry as season changes. So there's bound to be little movement, there's bound to be shrinkage at some point. So all these things happens below ground that are not visible to us. So that's why you have minimum settlement like that, because anyhow it must settle. So by the time you are having less thickness for your foundation wall, then you are calling for cracks and defects that you do not bargain for. So the code recommended 2 to 5, very good ground where you can still get away 150, 100. So that is that for this lecture. This is the general arrangement, and I've showed you the option. Now I want to state that this is not the final solution for this. It varies from one engineer to another. So don't think that okay, this is the perfect solution for this. No, this is just me acting as an engineer and doing something that I know that okay, it can be constructed, and it can be designed. So another engineer might pick this and you have something entirely different from what I have, and it will still be right. So there's no right or wrong kind of thinking here. So anybody can pick this and come up with another idea that will still be viable, that will still be constructible and be efficient as well. So there's rib slab that can be used. So it varies from person to person. What must be the same is that they must accurately account for every possible load that will be exerted on the structure and in turn exerted on the foundation. That is the only thing that can be the same. Every other thing else can be different. Somebody else can come up with another arrangement and it will still be right. So it is not a one solution fit all kind of thing. Anybody else can pick this and come up with another different solution that is entirely different from what I have done, and it will still be right. So thank you for joining me for this video. Then from in the next video, we will now talk of the preliminary parameters that you need to have, because that will determine the choices of some of these things. So like, what is the span, what is the useful life of the structure, 50 years for buildings, what is the exposure condition class. So those things come into play when by the time you are making choices for your cover and all that. So we'll cover that in the next video. Then subsequently also, like I won't be able to take all the elements and design manually, so we'll only pick a section of it. Like this cantilever will pick the section, they will pick one slab, the interior span, then the edge, then maybe one way span we will also treat, which can be replicated for others in a manual design. Then, like I said, as we progress, we will now model it in the software from scratch up to this point. So thank you for joining this video. I'll see you in the next video. Happy holidays. Bye for now.